Hello, this is notes. This video contains notes for section 2.2 from our calculus book, and topic is computing limits. So we talked a little bit about in class about what a limit is and why we are ultimately going to be very interested in limits as a tool for developing calculus. And now we're going to go through the basics of how to calculate some limits. We're going to be talking about limits today of this type. We have, what is the limit as x approaches some number, I'm just going to call that a generically, of some function of x. Right? The limit as x approaches a of some function of x. So let's look at a few examples first and just see what these things look like. Now, let's say we wanted to find what is the limit as x approaches 2 of x squared plus 2. Well, the first thing that you want to do, we could think about this graphically, like we were looking at many limits yesterday, and we could sketch a little graph of this. Now, I think you'll agree in a moment that this is really not very necessary to do this. So we could say, what's the limit as x approaches 2 of x squared plus 2? And we will easily see that we have a parabola that looks something like this, and here, as the x values get closer and closer to 2, the y values are getting closer and closer to 6. And there's no funny business going on here, right? There is not a hole here. There is not a vertical asymptote, and there is not a jump in the graph. So none of the things that give us pause to really think about limits, none of those things is happening here. Now, algebraically, the way that that shows up, or the way that presents itself, is that take the 2, plug it in, you get your answer, right? So what's the limit as x approaches 2 of x squared plus 2? It's what you get when you plug 2 into this. So that seems sort of trivial and not exciting, but it's important to realize that the reason the answer is 6, it's actually not because when you plug in 2 you get 6. It's because as you plug in numbers really, 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 really close to 2, this gets really, really, really close to 6. What actually happens when you get to 2 does not matter in the end. Although, in this case, when there's no jump hole or vertical asymptote, those two things happen to be the same. The number that you're getting super, super, super close to happens to also be the destination point, the point that's actually right there. Right? But that point does not actually have to be there for the limit to exist. And more about that in the coming examples. So, let me give you an example that's not so trivial. How about the limit as x approaches 2 of x squared minus 4 over x minus 2? I think we looked at that example yesterday also from a graphical point of view. Well, let's look at it now from a graphical point of view. We could, if you're not sure exactly what that looks like, you could make a table of values and say, let's see, if I plug in some numbers like negative 1, if I plug in negative 1 squared is 1 minus 4, that's negative 3 over negative 3, that would give me 1. And then if I plug in 0, that would give me negative 4 over negative 2, that's 2. And then if I plug in the number 1, I get 1 minus 4 is negative 3 over negative 1, that's 3. And when I plug in 2, I get 0 over 0. Well, what are we supposed to do about that? The first thing you should always do is plug in 2 here, right? So 0 over 0, not sure what to do about that. And then if we plug in 3, we get 9 minus 4, that's 5 over 3 minus 2, 1, so that's 5. And let's go one more if you're not convinced about what this pattern is here. So plug 4, that's 16 minus 4 is 12 over 4 minus 2, that would be 6. So, I mean, you could show this to your little cousin who's in kindergarten, and they could say, oh yeah, that should be 4, right? Because 1, 2, 3, question mark, 5, 6. Clearly we would like that to be 4. It would be very odd if it wasn't 4. But we need some kind of better justification than just looking at it and wanting there to be a pattern. So why is it 4? Well, if we take a closer look at this, when you saw this at first, you might have been champing at the bit, as they say, to factor it, because you have good algebra instincts. And when you see something like that, you think, let me factor it. Come on. So maybe you were thinking about that, and then maybe if you saw that and imagine what the factors were, maybe you saw that this is actually one of the factors, and you saw that, hey, those would cancel out. Well, that's fine as long as x is not equal to 2, right? You can't go canceling zeros out, right? That's not allowed. But as long as x is not actually equal to 2, then in fact those do cancel out. So what we've just found is this means that x squared minus 4 over x minus 2, that's actually equal to x plus 2 all the time, except when x is equal to 2, right? This is absolutely 100% true statement if x is not equal to 2. If x is equal to 2, then it's 0 over 0, and that's no good, right? So you can see here, how do we do this algebraically? We do it by factoring and canceling. We say that's just x plus 2 times x minus 2 over x minus 2. Those cancel out. Plug the 2 in, and that means the limit as x approaches 2 of x plus 2. Now I can plug the 2 in just like I did up here. That's equal to 4. Right? So it is 4. Your little cousin was right. But this is the justification for that. Now you say, what about this problem? What about x not being equal to 2? Oops, can you see that? That's off the screen. Let me just slide that over. See, if x is not equal to 2, right? So what about that problem? Because, I mean, that's exactly the spot where we were interested. You know, that's the point that we were interested in. That's the x value that we were supposed to approach. So why is it not a problem? For the same problem here, remember that it wasn't actually important what happened when x was equal to 2. It's all about what happens when x gets really, really, really close to 2. And as x gets really, really, really close to 2, so long as it's not actually equal to 2, then this is actually just equal to x plus 2, and you can cancel those. Now, to complete our understanding of what just happened here, let's just take a look at what this graph looks like. So we have negative 1, 1, 0, 2, 1, 3, 2, question mark, and so on and so on. If we were to graph this, it is a straight line. What line is it? Well, it's the line y equals x plus 2, right? It's got a slope of 1, y-intercept of 2. And the only thing that makes it different from the actual line y equals x plus 2 is that it has a hole here. This one point is missing. Why? Because you cannot plug 2 into this. Right? If you plug 2 in, you get 0 over 0. And that brings us to the next definition. And this definition will be more complete by the end of the next section. Definition. We call 0 over 0 an indeterminate form. Now, what does that mean? Well, indeterminate. I think you could figure out what that means. This prefix means not, right? And determinate would be something that you can determine, right? So this means cannot be determined. So if you have a limit, like this one, for example, and you dutifully plug in this number, it's the first thing you should always do, check out what's going on. If you get a number here, if you get anything like a number over 0 or 0 over a number, those are all determinate forms. You can report an answer right away. But here, if you get 0 over 0, that is an indeterminate form. And what does that mean? It means you cannot tell what the answer is at that point. So what do? You do some algebra. Maybe you factor and cancel. Maybe you do some other kind of algebra. And I'll show you the other kind that you might have to do in just a second. Before we do that, let's just take a look at a couple more quick examples. So what is the limit as x approaches 1 of, let's see, x minus 1 over x squared minus 2x plus, minus 3. Let's see if I did that right. Try to make one up in my head here that will factor there how I want it to. That's the minus sign right there. So let's see. We try plugging in the 1. We get 1 minus 1. That's 0. And then we plug the 1 in down here, and we get 1 minus 2. Let's try that instead. We get 1 plus 2 minus 3. That's going to give me a 0 on the bottom. So that's 0 over 0. So that means we can't just plug in the 1 and get the answer. So what do? We factor. So that's the same as x minus 1 over, this would give me x minus 1 over x plus 3. Those cancel out. That would leave a 1 on the top, right? And now the problem's gone, right? We've canceled out the problem, and we now can plug in the 1, and 1 over 1 plus 3, or in other words, 1/4. How about that? What does this look like? Does this look like a line also? The answer to that question is no, and I challenge you to take this, after the x minus 1's canceled out, and make a sketch of the graph of this without your calculator, including the spot where the hole is. Okay? Take a minute, pause the video, and try to do that, please. Here's another example. What's the limit as x approaches 2 of this same x minus 1 over x squared plus 2x minus 3? Should we just take the 2 and plug it in there? Well, actually, you could do that, but the first thing you should do is just try plugging it in here. So 2, that's 2 minus 1. So right off the bat on the top, I'm not getting a 0. So this is not indeterminate. Or in other words, it's a determinate form. I can just plug the 2 in and get the answer. And then we have, let's see, 4 plus 4 minus 3. That's 8 minus 3, and that's 5. So that's just 1/5. Done. So the first thing you always should do is plug the 2 in, see what you get, because you never know. It might not be a crazy kind of limit after all. What is the limit as x approaches 1 of, let's try 5x over x minus 1. Plugging 1 in there, I get 5 over 0. Well, there's a 0 there, and you can't divide by 0, so this is some kind of undefined. But should we report it as undefined, or should we report it as positive or negative infinity relative to our one-sided limits? I think you need to investigate a little bit what's going on here. Let's first let's check both sides. We know that this is going to be, there's some kind of vertical asymptote in the graph of this because of the 0 on the bottom. So what's happening? Are both things approaching up like this? Is it one of these kind of situations? Is it both going down? What's happening? So let's see if we can figure that out. If we try numbers, let's see, what is the limit as x approaches 1 from the positive side? If I plug in some number just a tiny bit bigger than 1, this would be positive, and this would be a little bit bigger than 1, minus 1, which would be a tiny but positive number. That would be positive infinity. And the limit as x approaches 1 from the negative side, or from underneath 1, this would still be positive, right? 0.999 or something like that, times 5. And then here, I have something a little bit smaller than 1, minus 1. That would be a very small negative number. So positive divided by very small negative, that's going to be going to negative infinity. So we say, since these are different, they do not agree, we say that the limit does not exist. The limit does not exist. Sometimes that's the right thing to say. Now, here's another example. What is the limit as x approaches, let's say 4 of the square root of x minus 2 over x minus 4? Well, you try plugging the 4 in, you get 2 minus 2 over 4 minus 4, that's 0 over 0, that is an indeterminate form. So you need to do some algebra. And again, what do you think? Maybe pause the video for a second and think about what you might do to this. You can't factor and cancel, but there's another algebra trick or an algebra skill that you have that is the right one to apply here. Pause the video. Think about it. If you thought that you should multiply by the conjugate of this, you were right. Why would that work? Well, you'll see in a minute. But your instincts often are going to be correct, even if you don't know exactly why you're having the instinct that you're having. It's because you were well trained in algebra. Square root of x, I'm foiling these two things out, right? That's the difference of two squares, so that's going to give me x minus 4. And then on the bottom, I'm not going to multiply these out because see what's happening there? I have an x minus 4 times the square root of x plus 2. Those cancel out. Now I can plug in that. Notice the 0 over 0, that's the thing that we're hoping will cancel out. And it did. And then I can plug in my 4, that's 1 over the square root, that's 1/4. How about that? Pretty neat. And those are the basic tricks that you are going to be using to do the homework problems. And I don't think that I need to say any more. Any other questions that you have, I will be able to answer for you in class.